Okay, for this first lesson on sequences and series, the arithmetic sequences, you're invited to pause the video and just complete this first page on your own, because I think given prior skills, you could probably do this page without any assistance. So feel free to pause the video. Okay, if you did go ahead and do that, great. There's probably only a few tricky ones on this page. Okay, I do often say to students just to make double sure by checking between two terms that the pattern remains the same, because sometimes you can be tricked. They can switch from an add to a multiply, etc. So this first one, A, would be an add 5. The second one is add 6, right? They do ask us to describe the pattern. And so, of course, this would be 29 and 35. The next one is subtract 2, right? We're subtracting 2 and subtracting 2. Okay. And, of course, for question D, D is a little bit tricky, but we have to figure out what are we adding to go between 13 and 27. Okay, it's arithmetic sequence, so we're just adding something, and there's sort of a couple of tricks to do that. We know that to get from 13, we would be adding two differences to get to 27. Okay, 13 plus some difference plus another difference would give us 27. So I'm going to subtract 13 from both sides, and we get 2D is 14. So our difference there would be 7. So add 7 is our difference. And some of you might just have been able to eyeball that. It's in the middle, right? It was in the middle of 27 and 13. So we could also have said the middle of 27 and 13, right? Some of you might have said 27 plus 13 divided by 2 is 40 divided by 2, which is 20. Okay? And then, of course, adding 7 gives us 34 and 41. Now, similarly with this one, okay, I'm going to use the differences trick. I'm literally from the 5th term to the first term, we're adding 4 differences. So 4 plus 4 differences is equal to 20. So 4 differences is equal to 16. And we subtract 4. And D is 4. Our difference is 4. Now you might not, if you've done this yourself, you might not have done this in this way with these terms, but of course I'm introducing you to some of the terms. Okay, here we can see it's add 3 and add 3. So going backwards, I'm going to subtract 3. Our first term there would be a negative 2. All right, determine the first 5 terms. If the first term is 7, okay, the term 1 is 7. We're just going to identify T1 with a little subscript 1. Okay, T1 equals 7. That means our first term is 7. And we want the first 5 terms. So the first term would be 7, increasing by 8, 15, 23, 31, and 39. Okay, if the 6th term is 9 and the 7th term is 18, so if T6, is negative 9, and T7 is negative 13, the difference between those, okay, to go from negative 9 to negative 13, that's a subtract 4, isn't it? So to get term 1, 2, 3, 4, 5, I guess term 6 was negative 9 and term 7 was negative 13. That's a subtract 4, going in the right direction. So if we're going in the other direction, we're going to add 4. That's a negative 5 and a negative 1 and a 3 and a 7 and 11. Okay, the first term is 6 and the fourth term is 39. So what I would do here is I would really just write that out. T1, T2, T3, T4 is 39, and T5. Similar to what we have up here for like question E. All right, so how many differences from term 1 to term 4? We've got 3 differences. So 6 plus 3 differences is equal to 39. Subtract 6 from both sides. Our difference is 11. So there's our terms there. Okay, we're adding 11 and so on. Okay, what I want to actually do is skip questions 3 and 4. If you've discovered them, okay, those are sort of more discovery questions for now. But there are formulas and such that we'll look at in the next lesson here, and then we can go back to those. Okay, so what is an arithmetic sequence? Well, an arithmetic sequence is, an ordered set of numbers. Okay, a sequence is an ordered list of numbers, and an arithmetic sequence is actually when there's a common difference in between each. So we've been looking up here at arithmetic sequences. So a sequence, the terms of a sequence are labeled according to their position in the sequence. So the first term we would call T1. Okay, and we use that little subscript down there below. That means we're in the first term. Okay, the number of terms in the sequence is n. N is the number of terms, and the general term would be Tn. So that might be where we don't know a specific term. We could say, for example, Tn is 17. And we don't know which term number that is, but it could be a number in a sequence. So a finite sequence always has a finite number of terms. These ones stop, right? They stop, they do not keep going. Okay, and an infinite sequence has an infinite number of terms. They do not stop. All right. Now, what's an arithmetic sequence? If I look, I kind of want to check a couple of terms at least. It looks like we're adding 5 and adding 5 and adding 5. So this is indeed an arithmetic sequence. This one here, we're adding 2, and then we're adding 4, and then we're adding 8. And some of you might see already that we're just multiplying by 2. Okay, so this is not arithmetic. This is a geometric sequence. And this next one here, question C, is we're subtracting 3 and subtracting 3 and subtracting 3, or adding a negative 3. So that is also an arithmetic sequence. So an arithmetic sequence is an ordered list of terms in which the difference between the consecutive terms is constant. Okay, the constant is called the common difference. And the formula for the general term can help us to find more terms of a sequence. So this is what I didn't want to show you up above because I thought there's other ways to kind of guess and test and figure that out. But we'll examine and develop the general term of the sequence right now. So if our first term in this sequence is 10, and our second term is 16, and our third term is 22, and our fourth term is 28, what we've done is we've written those out, the sequence value. So the value expressed in using the first term and the common difference, here we would say this is just simply 10 by itself. Okay, if I wanted to write 16 with respect to the first term, that's actually equal to 10 plus 6, right? And if I wanted to express 22 in terms of the first term and the common difference, I would be doing 10 plus 6 plus 6, right? We're adding 6 to get 16, we're adding another 6 to get 22, and 28 back with respect to the first term would be 10 plus 6 plus 6 plus 6. So if I look at my general sequence formula, if I want to kind of develop this, then what I notice is here is that I've got, for the first term here, for term 1, we've got 10 plus no 6s. For term 2, we've got 10 plus 1 6. For term 3, we've got 10 plus 2 6s. And for term 4, 10 plus 3 6s. So probably many of you can see the pattern already. If I wanted to term 7, I would say I've got 10 plus 6 differences, okay? So whatever this number is, this is 1 less. And if this is Tn, where n is 7, this would be n minus 1, okay? So our first term being the 10, T1, plus 1 less than the term number we're looking for, number of differences. And this is our general term formula, which is Tn is our first term plus 1 from our number times the differences, whatever our n is. So for example, write the first 4 terms of each arithmetic sequence for the given value of T1 and D. So my first term, 4, difference of 5. Next term is going to be 9, 14, and 19. Okay, we want the first 4 terms. So we don't need a formula there at all. Okay, our second, we can just write them down. Our second example here, our first term is 2, difference of -3. So I'm going to subtract 3 to give me -1. Right here we were adding 5 and adding 5. Here we're subtracting 3 and subtracting 3. So my next term is going to be -4, and the next one is going to be -7. Example 2 says, for each arithmetic sequence, determine the values of T1 and D and state the missing terms of the sequence. So for this first one, I can see, because there's some consecutive terms there, that my difference is 4, right? We're adding 4. So we're just going to go in the other direction. We're going to subtract 4, which means I've got a 1 and a -3. Okay, so T1 is -3, and our difference there, our common difference is 4, right? From left to right, we're adding 4. Question B, we don't have consecutive terms here, so what we want to do is, I know this is term 2 and this is term 5. That's 3 differences. So 6 plus 3 differences gives me 30. Okay, 6 plus 3 differences. So 3 differences would be equal to 24. We subtract 6 and dividing by 3, the common difference here is going to be 8. Right, so 6 plus 8 would be 14, plus 8 is 22, plus 8 is 30. Okay, and this one, of course, would be a -2 if we go in the other direction. So for the first examples, we could just write down we had no missing information. A, we could just look and figure out the missing information. This one we had to create sort of a little formula, okay? When we have missing blanks and it's not consecutive, okay? There's no consecutive terms. What we're going to do is we're going to create a little formula, okay? And it's our first term that we have, right? Our term plus the number of differences equals some other term. Okay? And then we solved for D. Now this next question says, determine the number of terms in each sequence. So I'm going to use my Tn formula for this one, okay? Because I don't know how many differences there are, right? We don't know how many differences, but we know we've got this little formula. And so this given term, some term number where we don't know what n is equal to 49. Okay? And if we look, this is our first term. Our first term is 4. And we can see that our common difference, okay, our common difference here is 3. So we're just going to plug this in. We know that 49 is equal to the last term, some term. 4 is our first term. We don't know what that term number is, but we know our common difference here is 3. Now what to do with this algebra here? Okay, there's a couple things we can do. I'm going to subtract, first of all, we're going to subtract the 4. Okay, and if we subtract 4 there, 49 minus 4 is 45. So there's actually two approaches algebraically to this. We can divide both sides by 3 and get 15 is equal to n minus 1, so n is equal to 16. This is our 16th term. T16 is 49. Okay, our 16th term is 49. Or if I hadn't solved that way, we could also have done this. We could have distributed, okay, I'll just rewrite this here. We could have said 45 is n minus 1 times 3, and we could have distributed this 3 in, we'll get the same solution, 3n minus 3. If I move over that negative 3, right, that becomes a plus 3. So we get 48 is equal to 3n, and n is 16. So either way you slice it, we get that same answer. Okay? I would pause the video and give this next one a try. Okay, if you had a chance to try that next one, great. If you're a little bit stuck, we'll just review it really quickly. So what I would do is I would start with this general term formula. Okay, as soon as I've determined that this is arithmetic, which I think it is, if I look here, we are subtracting 4 and subtracting 4. So our common difference here, I'm just going to write down what we know. We know our common difference is a minus 4. Okay, we know our first term is a negative 52. Okay, there's our term 1. And our last term, or some term that we don't know, our some term number, we don't know what n is negative 148. Okay, n is what we don't know. But if we look at this formula here, we can fill out every single thing in here except for n, which is what we're asked to find, the number of terms. So Tn is negative 148. That first term, negative 52, plus n minus 1 times that common difference of negative 4. So of course, algebraically, we know there's a couple of ways to do this, but what I'm going to do is I'm going to first just isolate my variables a little bit by adding this 52 to both sides. Okay. And of course, negative 148 plus 52 would be negative 96. And that's equal to n minus 1 times a negative 4. So I can distribute that negative 4 in to the n minus 1, or I can just divide both sides by negative 4, which might be a little easier. So we get a positive 24 is n minus 1. So n is equal to 25. Right, when we move that minus 1 over, that becomes plus 1. So there is our n. There's the number of terms. And actually back here, n was 16, okay, that we were just really asked to find the number of terms. But we could write this as T25 then. We know that T25 is negative 148, okay? It's the 25th term. There's our n value. So hopefully that's not too difficult, especially if you have the formulas right in front of you. You can always, you don't have to memorize them. You can always just grab those and fill them in. All right, let's look at the next example. It says, consider the sequence. Determine the formula for the general term of the sequence. So we have a general term formula, okay? Our general term formula, which is Tn, is T1 plus n minus 1 times d. But that's our general term formula. That's like a formula that works for all sequences, okay? This is for all sequences. Arithmetic sequences, we should say. Okay? But now sometimes we want a formula for the general term of this specific, okay? Okay, the formula for the general term of this specific sequence, okay? This is this specific sequence. So I could actually take this formula, this first formula, the general term, which is Tn is T1 plus n minus 1 times d. And I can fill in what I know from this formula. So of course from this sequence, my first term is 12. Okay, our difference here is a minus 7, right? We're subtracting 7, subtracting 7. So I know that my whatever term number I want, my first term is 12. And then I've got a negative, n minus 1 times a negative 7 for my difference. And then what we can do is we can simplify, okay? So we fill in what we have, okay? We know that T1, and we know our difference was negative 7. So we fill in those two things, and then we simplify. And then we've got a specific formula that's a little bit more simplified for this particular sequence. So if I rearrange this a little bit, right, I'm going to just distribute this negative 7 back, and we're going to get a minus 7n plus 7, right? We have to be careful with our signs there. N times negative 7 and negative 1 times negative 7. And then, of course, we've got a couple of like terms that we can add. And so our general term for this specific sequence is 19 minus 7n. We get that from the 7 plus 12. Okay, so that's a specific formula that's sort of been simplified for this particular sequence. So now instead of using the longer formula, now I would know if I want to find term 19, I can just plug that into this 19 minus 7 times 19, which is 19 minus 7 times 19, which is 133. And so term 19 would actually be negative 114. Okay? So if we ask for the general term of a sequence, it means basically we're taking our general term formula and we're simplifying it for this specific sequence. Okay? Now, which of the numbers, negative 268 and negative 350, are terms of this sequence? Well, there's a few things we could do there. Okay, I'm going to use this simplified formula. So I've got Tn is 19 minus 7n. And I know if these are terms in the sequence, okay, then n would have to be a whole number. Okay, n would have to be a whole number. So if I plug in negative 268 here and try solving for n, well, negative 268 minus 19 okay, subtracting the 19 there, would be negative 287, and that's equal to negative 7n. And if I divide both sides by negative 7, just using my calculator here, I get n is 41. So negative 268 is T41. Okay, so we know that that's a term in the sequence. And if we try that again with negative 350, and let's just see, does that look like it's going to be, if I subtract 19, right, we get negative 369 equal to negative 7n. And we get here, divided by negative 7, n is 52.7, right? And we can't have a partial term, right? It's either a term or it's not a term, okay? So we know that negative 350 is not a term in the sequence. Okay. Okay, for this next example, it says determine a particular term. So a visual and performing arts group wants to hire a community events leader. The person will be paid $12 for the first hour of work, $19 for 2 hours of work, $26 for 3 hours of work, and so on. Write the general term that you could use to determine the pay for any number of hours of work. So this is one of those examples where we're going to start with that general term formula. So Tn is T1 plus n minus 1 times d. So it looks like our first term up here is 12. Okay, there's our term 1. Our second term is 19, term 2. Our third term is 26, T3. And according to my math, our difference there is 7. So our Tn would be 12 plus n minus 1 times 7. So we're going to take that general term formula that's on our formula sheet, and we're just going to simplify that for this specific sequence. And that's exactly what we're going to do now. I'm going to distribute this backwards, this 7. Okay, and then I'm going to collect my like terms. So that's plus 7n minus 7. So Tn is 12 minus 7, right? Our two like terms there are the constants. 12 minus 7, which is 5 plus 7n, or 7n plus 5. So that's our general term for this specific sequence. So then, of course, what will the person get paid for 6 hours of work? If n is 6, T6 would be 5 plus 7 times 6, which would be 5 plus 42, which would be $47. Okay? $47 would be paid for 6 hours of work. All right. So I'm going to invite you to pause the video and see if you can figure out. All right, so hopefully you tried this one here, the your turn. Yeah, I would like you to try this one. I guess the trick with this one is it's very similar, but note that term 1, okay, term 1, because term 1 is at age 3, and term 2 is at age 4, wherever the term number is, the age is n plus 2. So for example, it says, how tall is the child expected to be at age 10? So at age 10, okay, age 10, right, this was age 3 was term 1, age 2 was term 4. So age 10 is actually going to be T8, okay, term number 8, because it's 2 subtract, right, minus 2, minus 2. So we're just looking for that pattern. So hopefully you figured this out, that at age 10 the child would be expected to be 105 centimeters tall. If you didn't do that on your own, then maybe pause the video and go through that solution. Now, let's look at the next couple of questions. The example number 6 says the third and eighth term of an arithmetic sequence are 12 and negative 18 respectively. Determine the values of the first term, the common difference, and the fifth term of the sequence. So if we know T3, sometimes I like to just draw a little picture here. T3 is 12. Okay, we've got T4, T5, T6, T7, and T8. This is an easy one because there's only a few terms. We can easily write those few spaces. Well, if I go from 8 to 3, there's 5 differences, right? There's 5 differences. So 12 plus 5 differences is equal to negative 18. And so we just need to solve for D. We're going to subtract the 12 there. So negative 18 minus 12, that's negative 30. And when we divide both sides by 5, D is negative 6. Okay, So 12 take away 6 is 6 and 0 and -6 and -12 and -18. So that was the third term. We filled in everything else. We found our common difference. Okay, we had to find our difference, which was 6. The fifth term, okay, we just found, which is T5, which is -6. And then, of course, going backwards to find our second and first term, we would go add 6. So term 1 is 24. And we could have done that more sophisticatedly. We could have used the formula, but it was 2 terms away, so it seemed pretty easy just to add 6 twice. All right, make sure we answered all the questions. The first term, the common difference, and the fifth term. Oh, I just realized 3, 4. Oh, I can't count here. This is term 5 should be 0, not -6. Sorry. Term 5 should be 0. Term 6 is -6. Okay. That should be term 6. I just can't count my terms there. Sorry about that. All right. Now let's take a look at the last question here. Example number 7. Okay, so how many multiples of 12 are there between 179 and 892? So what I want to do is basically look at 179 and 892. Well, are they themselves multiples? If I take 179 and divide by 12 and just plug that into my calculator, I get 14.916. Definitely 179 is not a multiple of 12. And same with 892. If we divide 892 by 12, we get 74.333. So 892 is not a multiple of 12, nor is 179 a multiple of 12. Because for something to be a multiple of 12, it would need to be divisible by 12. So our first term, all of the multiples of 12 in between, right? We're going to look for those number of multiples. Okay, there's a whole bunch of them. And it looks like the smallest multiple of 12, I'm going to call this term 1. Okay, the smallest multiple of 12 between 179 and 892 would be 12 times 15, right? So 12 times 15 is 180. So my smallest multiple of 12 would be 180. So we had to go a little bit bigger, okay? We had to go a little bit bigger because we want numbers between 179. So bigger would be the 15th, right? 15th multiple of 12. And then smaller than 892, okay? We need to go smaller, less than 892, would be 74. So 12 times 74. 74th multiple of 12. And 12 times 74 is 888. So this is our last multiple of 12 in between 179 and 892. And then, of course, there's a bunch in between. This next one would be 192, and this would be what would that be? 12. 204. Okay, and then what would the next one be? 216, and so on. Okay. So how many are there? Well, we know we've got this lovely little formula. What do we know here? We know our last term. We know what our last term is. We just don't know what term number it is. Okay, we know our first term, and we know our common difference, right? Our common difference, multiples of 12, our difference is 12. So I'm going to use our general term formula, T1 plus n minus 1 times t. So Tn is 888. I know the term. I don't know what n is. Term 1 is 180. and the common difference there is 12. So to solve for n, we're going to subtract that 180. So 888 minus 180, 708. And divide by 12. So n minus 1 is 59. So n is 60. There are 60 multiples of 12. Between 179 and 892. Now, there's another way to do this question, which I kind of alluded to. I know that my 15th multiple of 12, okay, the 15th multiple of 12, if you're just looking at multiples of 12, T15 would be 180, T74 would be 888. So 74 minus 15 is 59. We have to add 1 to make it inclusive, which means there are 60 terms. So for example, what I mean by that is if I was just adding the terms, just as a mini example, if I were saying how many terms are there that are multiples of 2 between 0 and 10, well, we would say, well, there's 1, 2, 3, 4, 5 of them. Okay, term 1, term 2, term 3, term 4, term 5. And so T5, right, 5 minus 1 would be 4, but we can see that there's 5 of them. So we have to add 1 to make it inclusive. The add 1 is the trick. Okay? And that comes from just making it inclusive. All right, hopefully that explains things pretty well. You can do this question either way if this doesn't quite make sense, but there we go. Have a look at your assignment booklet, Arithmetic Sequences, and if you have any questions or concerns, please do not hesitate to get a hold of your teacher. Thank you.